Look at this programmer operating a 1970s IBM mainframe. This era defined a specific computing philosophy: process one discrete step at a time, save the file, and load the next. Today, that exact step-by-step logic is still used to perform standard tasks, like filtering and reshaping an SDTM dataset into an FDA-compliant demographic summary. This split screen shows two ways to build that exact same summary. On the left, the standard SAS approach requires 47 lines of code across 5 distinct procedures. On the right, modern R achieves identical results in 12 lines. Reducing code volume by 75% requires a change in how we structure logic. It means moving away from saving temporary, disconnected datasets and building a single, unbroken data pipeline. SAS starts with proc SQL to filter out screen failures, followed by proc sort. But the R pipeline handles both immediately. The pipe operator passes filtered data directly into the grouping function in memory, bypassing temporary datasets. Next, SAS encounters friction, requiring proc means for statistics, then a separate data step using put just to format them. In R, wrapping the math inside the summarize function's sprintf passes calculated numbers directly into text placeholders. Calculating and formatting in the same step reduces a programmer's cognitive load. If a calculation breaks, you can check the specific line in the pipeline instead of hunting through invisible intermediate data files. This table represents our current in-memory data. We need to split the results by sex. Take a few seconds to think about which specific functions are required to pivot this dataset. If you weren't sure which function to use, it is because reshaping is where SAS and R diverge the most. SAS uses one proc transpose step, while R requires a two-part maneuver. For step 1, we apply pivot longer, pulling the n count, mean, and range out of separate columns and stacking them vertically. Then, pivot wider takes that unified column, separates it by sex, and spreads the values outwards across treatment arms. While this two-step pivot requires a shift in how you visualize data structure, mastering this sequence is necessary for continuous data reshaping. As you can see in this overlay, the dataset produced by the 12-line R pipeline is an identical row-for-row match to the output from the 47-line SAS script. This is the FDA. Because the statistical outputs are reproducible and accurate, regulatory bodies and pharmaceutical companies now actively accept clinical submissions programmed in R. This chart is your migration dictionary. Proc SQL maps to filter. Proc sort becomes group by. Proc means is replaced by summarize. Put formatting shifts to sprintf. And proc transpose converts to the pivot longer and pivot wider sequence. You should screenshot this dictionary. Developing dual language proficiency is the most direct way to future-proof your career in clinical programming, allowing you to maintain legacy systems while taking advantage of modern data pipelines.